finance, markets, and politics at fattailedandhappy.com. Follow us at Twitter at fattailedhappy. Hey guys, thanks for tuning in to another lesson on the Fat Tailed and Happy YouTube channel. Volatility is all the rage in the stock market as of December 2018, with the stock market going like crazy. In this lesson, we're going to start to build the building blocks to describe what is volatility. And in order to do that, we need to discuss the concepts of variance and standard deviation. Now, for anybody who wants a little bit of a background on this, you can go to the fattailedandhappy.com website and check out the prior blog posts on random variables and distributions, and that will give a little bit of a flavor, or you can just follow along here. So, without further ado, let's just dive right into it. When we're talking about variance and standard deviation, what we're talking about is that there is just, purely how much something moves around is important in and of itself. Everybody kind of gets a average of something, like the Dow Jones Industrial Average has a level associated with it, currently something in the 20,000s. Volatility is just another concept to say, rather than looking at the level of something, we're interested in the variation of something. How much does it move around? And calculating standard deviations and variance allow us to be able to compare a couple of different things to say which one is more volatile than something else. That's all they mean. So we'll take a ground-up view of how these formulas are actually derived, and hopefully that will lead further on down the road when we talk about random walks and actual volatility itself. But the basic concept, I think a lot of people struggle with standard deviation, and it's really a pretty easy thing. So let's just get after it. Okay, so let's say we live in a city. We'll call it city number 1, and it's got some temperature data with it, associated with it. It starts on day 1, it's going to be 75 degrees, and then 80, 70, 65, 68, 58, and then a cold front comes through, and maybe it's 47. So that's 7 days over the course of a week, over which the temperature in the city averages out to 66 degrees. And then over here, let's say we've got another city, and maybe it's a little bit cooler. It starts at 55, 47. Okay. And its average temperature, indeed, is cooler at 53 degrees. So we would like to compare these two cities to say, all right, which one has a more variable climate? Now, maybe one thing we can do, let's take a naive approach to this. If we're interested to know how much something moves around average, approach number 1, let's just calculate the difference from average. Okay, so the difference from average, all I have to do on day 1 is calculate the day 1's beginning value, which was 75 degrees, and compare that against the average temperature. So it was 8 degrees warmer than average, day 2 was 13 degrees warmer, and so forth. Now we get these days in here that are actually cooler than average, and those are negative values. So if I was to actually add all of these things together, the problem is these add to 0. And if I do the same measurement over here, I need to change the target for that cell. But if I do the same operation here, I get 0 in both. That's not terribly useful. So one way to fix negative signs is just simply to square things. Any negative number squared results in a positive number. So let's try that. Let's just take these values squared. And gotta format these numbers down because that is way too many decimals. Okay, if I add these together, okay, well now actually I've got something. I can actually see city 1 is more variable than city 2 because the 722 is greater than the 302. Now this measurement, we're on our way, but we're still not quite there yet, because as I added more weeks and weeks of data, these numbers are just going to get bigger and bigger and bigger. So instead, I actually need to scale them to something. So instead of dividing by that, let's divide by 7. Over here, I'll divide by 7. Okay. Now we're getting very close to something. So all we've done, this says, on any given day, the difference squared divided by the total number is this value. And this is saying, okay, comparing these two, number 1 is much more variable than number 2. This is the basic structural formulation for variance. Now, for the pure statistics guys out there, rather than dividing by 7, you should actually be dividing by 6, because you have to divide by n minus 1. But I'm not going to get quite into that as to why you need to do that. If we're looking at stock market data and we've got thousands and thousands and thousands of observations, that n minus 1 doesn't really matter, because if I divide something by 1,000, it's pretty much the same as dividing it by 1,001. It's only in really small samples that this becomes a problem. But for purposes of this, you can just, if you didn't understand what I just said about the n minus 1, just don't worry about it. Okay. One alternate approach to actually compare the variation between the two is, since we squared this thing, perhaps we should unsquare it at the end. The way you unsquare something is you take the square root of it. And so I apply a square root here, and this is not exactly the standard deviation, but it's pretty close to it. Again, it's because of that n minus 1. So to prove that, I can use the actual standard deviation formula built within Excel. Oh, that's the wrong target. I should be using the temperature data. So if I use standard deviation, STDEV, on the actual temperature data itself, I get 10.97 degrees. And if I copy it over here for city number 2, I get 7.09. Now, our estimated up here was slightly smaller than that. And again, the reason for that is because I divided by n rather than n minus 1. So if I wanted to actually true this up, instead I should add everything up here, divide by 6, and then take the square root of that. And there I get my exact formula for standard deviation. And over here in city 2, I can again prove that that works. Okay? And it is really that simple. So what we've then done is we've calculated, by approach number 2, we had negative numbers were bad. So we have to square the differences. That results in either variance, what's called variance, if we leave it alone. If we take the square root, we get standard deviation. And standard deviation is really that simple. It allows us then to say city number 2 is a more stable climate than city number 1. Now when we talk about stock market volatility, we're going to be talking about percentage changes in the movements of stocks. But otherwise, volatility that you see in the VIX and anything else that refers to an actual standard deviation, calculated exactly in this manner that we've described here. So I hope you've enjoyed this brief video. That's it for now, and please send any comments on. You can contact Twitter at fattailedhappy, or you can swing by fattailedandhappy.com and contact us over there. See you next time. Thanks.